Okay, so far you guys have studied parallelograms and rectangles. Today we're going to actually double up. I'm not doing any proofs. You can see down here it says coming soon, but I'm not going to record that. The proofs for rhombuses and squares are extremely long. So you'll see today that I'm just combining these two because the lesson's like essentially really short. I am going to do some examples today just to kind of get you guys thinking, because there's lots of different types of questions you could see. But at the end of the day, I want to remind you guys that what you need to know are the things that are in the boxes. So hopefully you've been studying because that is going to be, again, like the triangles test, like the most important part is that you know these properties. So parallelograms, opposite sides are parallel, opposite sides are congruent, and opposite angles are congruent. The diagonals bisect each other. And I'm just spitting these things out off the top of my head, okay? A rectangle, what's special about a rectangle is that all four angles are the same. They're all 90. They're congruent. And the diagonals are also congruent, okay? So that makes a rectangle special. It's a special type of parallelogram. So the next special type of parallelogram, unrelated to a rectangle, is a rhombus. So a lot of you probably remember from elementary school or middle school, rhombus is like a square that's slanted. And so a rhombus is a parallelogram, but it has four congruent sides. It also has like opposite sides parallel, opposite sides congruent, just like a parallelogram. And just like a parallelogram, opposite angles are also congruent. So you've got a shape where all four sides are the same and the angles across from each other are congruent. What's interesting about a rhombus is the diagonals are not congruent. Remember, that's a rectangle. Instead, they're actually perpendicular. I'm going to put perpendicular bisectors because remember, a rhombus is a parallelogram. Well, parallelogram has diagonals that bisect each other. So they're perpendicular, but they also bisect each other. So I'm going to call them perpendicular bisectors. Remember, bisect means to like chop everything in half. The diagonals, this is also special about rhombuses. So in a rhombus, opposite angles are congruent, but when the diagonals are drawn in, the diagonals actually bisect the angles as well. So in each corner, if you have a diagonal drawn, the little angles that's getting drawn into, they're going to be the same. It's going to split it right in half. So that's kind of interesting. Now, what I want you to envision is if I draw in these diagonals, I'm going to have sides that are congruent. And so what you actually end up creating is isosceles triangles. So hopefully you did your geometry review packet. If you didn't, in an isosceles triangle, you have two sides congruent, and the angles opposite of that, the base angles, are congruent as well. So that's going to help us. In example 1, find the measure of each numbered angle in the given rhombus. This is all about angles. So opposite angles are congruent. So if this is 104, this is 104. It's not asking me for that. But you can see that this diagonal has been drawn in. We know that this angle and this angle is going to be the same, and they're also going to be split in half. So 1, 2, 3, and 4 are all going to be equal. We just need to figure out what they are. Well, I've got a triangle right here, and triangle sum theorem says this triangle should equal 180. So 180 minus 104 is 76. That's what these two angles equal, so I'm going to divide it in half because remember, these two sides are congruent, and in an isosceles triangle, the angles are also congruent across from the sides. So I'm going to divide it in half, which is, what, 38? So all of these angles actually are 38, 38, 38, and 38. That angle right there is 104. All right, in B, it's kind of backwards. So I've got a rhombus. The diagonal is drawn in, so you can see two isosceles triangles. But again, if this side and this side's congruent, the angles are also congruent. So if this is 54, this is 54. The angles are bisected in a rhombus. So if that's 54, this is 54. And we just need to figure out what 1 and 4 are. 1 and 4 are going to be the same, because a rhombus is a parallelogram and opposite angles are congruent. So again, triangle sum theorem. So 54 plus 54 is 108, and 180 minus 108 is 72. So this is 72 and this is 72. Okay, last one, C. I've got 59 in that bottom right corner. So if that's 59, this is 59. This is, let's see. Oh, okay, cool. So remember, let's do this corner over here first, sorry. This angle and this angle is the same. So if this piece is 59, this piece right here is also 59. And these are easy. This is something we haven't talked about yet. If the diagonals are perpendicular, that means that they form right angles. So what are 2 and 3? If these diagonals are perpendicular, aren't these right angles right here? So they're both 90 degrees. Super easy. Okay, cool. Last example, and then I'm actually going to stop the video, give you guys a second to catch up, and then we'll do squares. But it says find the measure of each segment in the given rhombus, so I don't really care about this angle at all. Let's start with around the outside, so this is easy. All of the sides are the same. So if this is 10, this is 10, this is 10, and this is 10. The diagonals are perpendicular and they bisect each other. So that means if this little piece is 8, this little piece is 8. Now here's where people get confused. These little pieces are not 8. That's only true in a rectangle, because in a rectangle, diagonals are congruent. Diagonals bisect each other and diagonals are perpendicular. They are not the same. So I don't know what this little piece is right here. Okay, but what I do know is that the diagonals are perpendicular. They don't only bisect each other, they're perpendicular. So in this corner right here, I have right angles all the way around. Well, do y'all see right here? I'll try to highlight it for you. This is a right triangle. So everything's going to start kind of coming together in this unit. So if I have a right triangle and I have 2 of the sides, I'm going to use Pythagorean theorem to figure out the missing side. So a squared plus b squared equals c squared. We'll call this a. So a squared plus 8 squared equals c squared. And we're going to solve for a. Okay, the square root of 36 is 6. So this is 6, and since they bisect each other, this is also 6.